Hello everyone and welcome to today's broadcast brought to you by U.S. Department of Energy Building Energy Codes Program. I'm Commentator at the Pacific Northwest National Laboratory, and we hold a webinar every other month at the same time. So it's the second week, Thursday, same time, 10 a.m. Pacific Standard Time. So the course description for today, today we'll be talking about bearing ducts and looking at the prescriptive requirements that are now in the 2018 International Energy Conservation Code. This training is going to provide you a brief look at how the buried ducts got into the code, some science backing to it, and a couple of things that we'll go through to how you would go about installing this an alternative measure if this is something that you'd like to do to bring into your construction practice. Next. So some learning objectives of what we'd like to make sure that you take away today is getting a brief overview of the research that's been done on ductworks and going into conditioned space and an unconditioned space. And a summary of what the code changes are. If you're not familiar with the code cycle, you might want to go out and take a look at that at IECC's website. Also a description of how builders in practice today can change as far as looking at practices of how they were doing things, so while they might want to modify those to maybe looking at doing buried ducts, and code will go into that. And an overview of a little bit on the energy and cost benefits of using this alternative method or this alternative approach to putting ducts in the attic. And then lastly, the synopsis of relevant field research, providing most of that practices by showing them how this can be effectively done and how safely it can be done in all climate zones, even in the hot and humid climates. So I'd like to introduce to you today is Craig Drumheller. And he is the director of the Construction Codes and Standards for the National Association of Home Builders. He's been with NEC for quite some time, and I will have to say that congratulations to Craig that he is the one that took the lead to get these code changes in place for the 2018. Put a lot of effort into it, and so he's going to provide you what happened in the history of how we got to where we are and how Building America Research got us there in the long run as well, too. So, Craig, go ahead.
Okay, thank you, Pam. About 2 years ago, the subject of buried ducts came up in an NHB meeting to discuss the prospective code changes for the upcoming cycle, which resulted in the 2018 code. And I was surprised at the interest level of the builders, and I even had personal experience, and back in my research days had been involved in buried ducts and some of the concerns and advantages of them. And I was kind of took the lead, but with a lot of help from people who had done previous research, from industry, from the installation industry, from builders and HVAC contractors, and really got a good team together. So I can't take full credit for this, but I was involved with it from the beginning, and was quite pleased with the life that it's taken on and the level of interest in this particular subject. So, what are buried ducts? If you listen carefully to the words, you might think of ducts buried under a slab, in the ground. That's not what it is, and if you don't listen carefully, you might hear something like buried ducts. So, be careful with your enunciation when you refer to buried ducts. And that's not what it is. Buried ducts are ducts buried within attic installations of vented attics. So this kind of shows how, what we really mean by buried ducts. So the ducts are in some respects outside of conditioned space, but in other respects within the conditioned space. And that's what we're going to be talking about today. So the advantages of buried ducts, first and foremost, it saves energy versus ducts that are exposed in the attic. And typically it's a lower cost solution to bringing ducts fully into conditioned spaces, depending on what the configuration of the house is. Single story, slab on grade, it's very, very difficult to get the ducts in conditioned space. And this is a very practical solution for those particular applications. It can be easily implemented. It doesn't require high-tech solutions. And it's something that a builder can go out and start doing today if their code official allows it. So buried ducts, versus attics or exposed ducts in the attic. Traditionally, thermal losses are somewhere in the 10 to 45% range. It's probably lower than that if you're going to start talking about today's code, where building tightness or duct tightness requirements are somewhere in the 4 CFM per 100 square foot level. So, we refer to that as a 4% leakage rate. And some of the thermal losses, if you go back when there were R-4 ducts, not all that long ago, you have considerable thermal losses. When you go up to R-8 ducts, obviously you cut that in half. But when you vary them, you can almost get a threefold reduction in the thermal losses. So there is significant benefits to be seen with the buried ducts. Interior, bringing the ducts inside conditioned space. Here are 4 or 5 examples of how ducts can be brought within the thermal envelope. I've got a couple slides coming up here to kind of go a little bit more into detail on the advantages and disadvantages of these approaches. So, for example, ducts in an unvented attic. There's some, I'm sure you all are getting some quick first impressions of that's a lot of spray foam. It does give you some design flexibility with your HVAC system, that you can basically put it anywhere in the attic, and you shouldn't have any problems. It is in conditioned space because of the location of the thermal envelope. Very expensive, and may increase the overall enclosure load, because rather than having just the attic floor be that area being the thermal boundary, now you've created the thermal boundary, lifted it up, and add more surface area to your building envelope, which could increase the enclosure load. Another solution is a duct where you drop the soffit from the traditional ceiling, and requires some in a lot of cases architectural integration that doesn't really affect the feel within the house. If you look over on the right side, where they're installing this, we'll say properly, to try to get the ducts in conditioned space, you can see that integrating or coordinating the trades can be very difficult. Typically, if you do it wrong, you would have a framer, and then you'd have drywall, or framer, mechanical contractor, and then the drywall, and then you're done. With this approach, you've got the framer, drywall, framer, HVAC contractor, and then you've got drywall again. So it's really not a solution that has really taken hold in the field. Another approach, and this is really limited to the integrated ducts within the floor trusses. You have to have deep open trusses, probably 14 inches, 12 inches may work in some circumstances, but this really only works if you have an interstitial space between floors, which would be a 1-story with a conditioned basement, or a 2-story, potentially on slab. So there are limitations, but it is another prospective solution. Duct in a modified truss, essentially modifying the truss to try to keep the duct truly within the thermal boundary and within the continuous air barrier. But again, you have the truss cord, or the coordination of the trade, having to do the ceiling, not using drywall, or essentially using drywall and doing things out of order. And again, something that's a solution that's out there, but it really hasn't gotten a lot of traction. So, concerns about buried ducts. So, one of the problems, and it is a potential problem, especially in humid climates, is condensation on the ducts. And we've tried to address that. The research has shown when it occurs, where it occurs, and hopefully we've taken care of that with these new changes in the code. Another is displaced attic insulation, at least in theory, resulting in reduced efficiency. Research has shown that is not the case. And a new concern with the ducts that are buried, research has shown that the temperature, the air conditioning delivery temperature, of course, this is really a summertime air conditioning issue. The temperature, the delivery temperature, could be 7 degrees cooler than previously if the ducts were outside and exposed in the attic. We could have we'll say a delivery temperature of somewhere on the order of 65 degrees, and now it could potentially be down in the 58-degree range. So a significant reduction in the temperature also increases the potential for condensation. So the buried duct research has been going on. Building America has really been a strong supporter of the buried duct concept for over 15 years. Stephen Winter Associates has really taken the lead or was an early researcher on this. They have some research really going back into the late 90s, but the Building America program really picked it up in early 2000, 2002, somewhere in that range, and done a number of papers. They've come up with a variety of solutions, including encapsulated ducts and recommended areas where it works and doesn't work and different R values. So they really have done a tremendous amount of research. Home Innovation Research Labs, formerly known as the NHB Research Center, where I used to work, recently did a paper back in 2016, and it showed in a humid climate that even an R8 duct should be able to work without it. They did it without any evidence of condensation. So there really is a safety factor built in some of the code changes that were incorporated. And also Florida Solar Energy Center has also done some research under the Building America name in the past 15 years. So here's an example of how the insulating of the ducts when they're buried, having the increased R value reduces the condensation potential. So this is at the boot, the surface boot, and it shows the peak RH, the peak relative humidity. If you look over on the right vertical bar, that's a relative humidity of about 90% for this particular application. And that's not really in the danger zone, but it's getting close. Just because you're having condensation isn't in itself a real problem. It's the extended periods of condensation is really where you start having a problem, where you start seeing things like staining and potentially mold growing after that. But this particular application, at least it shows that it's still in a safe zone. But when they applied insulation on the top, when they encapsulated the duct, this is basically this is the same system, and it's a different day, but relatively similar attic temperatures and relatively similar attic dew points. That same duct, the peak relative humidity is somewhere in the 70% range, and even earlier in the day where there's the potential to drive off the moisture later on if there were to be a problem. So it shows that insulating the ducts actually does make a big difference, or I should say additional insulation on the ducts makes a big difference as far as reduced moisture potential. So, as I also pointed out, that this reduced delivery temperature, and again, this is in the air conditioning mode, not the heating mode. So the reduced delivery temperature, which is actually a good thing, and the 7-degree reduction with the buried ducts clearly saves energy over exposed ducts, but it also increases the opportunity for condensation, most notably at the boot near the supply register. And so I'm using a slide on the picture on the right, I think helps illustrate where you would see a much colder temperature at the duct boot, where you would have a potential for condensation. So potential solutions for that would be having an insulated boot or putting closed cell spray foam over top of it. So there are solutions to this problem. Just wanted to be aware that we are changing some of the dynamics, and it may need some solutions to it. But this is really much more of a concern in the southeast than it is anywhere else in the country. So why the need for a code change? Some jurisdictions do not allow builders to bury ducts. They have concerns about condensation and concerns about reduced efficiency. A little embarrassed, but the slide on the right is actually a slide, is a picture in my attic, where the jurisdiction that I live in requires them to take the duct system and put it up as far as they possibly can in the attic. And it's just, when you think about it from a building science perspective, you think about it from an energy efficiency perspective, you are taking in the winter time or the summertime, the coldest air in the entire house, and you're putting it into the absolute hottest place in the entire house, and even the hottest part of the hottest place in the entire house, where the temperatures can be up to 160, 170, 180 degrees, and then the temperature of the conditioned air going through the ductwork is somewhere on the order of, we'll say, 50 to 60 degrees. So a very high delta T, why don't we lower that, put it into the attic insulation, and provide additional thermal benefit. And you can also see there when you have the ducts, the takeoff on the duct with the flex duct, that over time other things happen to it. So if you have it flat with the ground or flat with the backside of the attic insulation, you're not going to have these gravity effects on it as you would in a elevated location. So the concern was that there was no guidance in the code on how to address condensation, and a concern about the reduced efficiency. And so the idea was, why don't we incorporate this to explicitly allow ducts to be buried in attic, and provide criteria that we got a bunch of experts in the room to come to a consensus on how to best do that. So in addition to that, not only when you're burying the ducts are you getting the benefit of the reduced temperature, that you're also, with the change in the energy code, to allow builders to receive credit towards compliance, because it is a more efficient solution than ducts exposed in the attic. And also there was an alternate proposal, or an additional proposal, that would show equivalence to a duct being in conditioned space. So it consisted of 3 different proposals, as I indicated. One that said, yes, you can allow buried ducts along with criteria. Second, to get performance credit for buried ducts, and this was based on the research that was performed, and the alternate criteria for ducts in conditioned space. And these are the actual headers of the proposals that were submitted for the 2018 code, or 2016 code cycle, that ended up being the 2018 code. So ducts buried under insulation, it's a viable practice, where the ducts are placed basically on the back side or the top side of the ceiling drywall, over the bottom truss cords, we'll say for the transverse, the trunk line, and then typically the flex ducts or the takeoffs, it could be rigid ducts as well. The takeoffs would be on the back side of the drywall and going to the supply registers, which are typically towards the exterior walls. Although there are some shorter compressed duct runs as a solution, this would work with both of those, whether it's a short duct run or a longer duct run. It would be applicable to both. So the reduced thermal losses from ducts located in vented attics, and it considered condensation in humid climates. So prior code additions didn't specifically disallow buried ducts, but it also didn't specify, obviously, conditions of performance and compliance. So the 2018 code change proposal recognized the buried duct, specifying the insulated duct R value by climate zone, and which addressed moisture concerns, the minimum attic insulation around the duct, which addressed energy performance, and performance path energy compliance, which specified parameters to be entered in the software when you're doing performance modeling. So the code requirements for ducts buried within ceiling insulation: first, you have to have R8. Right now, R8 is the prescriptive requirement, but if you're doing a performance path, you can actually reduce it down to R6. But if you're going to bury the ducts for these considerations, you must have R8, and you can't back off to R6 and make it up somewhere else because of some of the concerns with condensation. And R13 rather than R8 would apply in climate zones 1A, 2A, and 3A. And the definition of the duct insulation, as opposed to the attic insulation, if you look at the three duct examples on the right-hand side, you might say, well, what's the distinction between the duct and the attic insulation? And that would be the vapor retarder. So that is really the defining point between where the duct insulation ends and where the attic insulation begins. And if you have encapsulated the duct, for example, with closed cell polyurethane foam, the duct insulation is extended right to the surface of that closed cell foam because of the low permeance of the foam, and also the jackets on the flex duct also are low perm, and for the purposes of keeping moisture from the outside coming into the duct and reaching the cold surface of the duct, that would be the extent of the duct insulation as well. So in the ceiling insulation, just to make sure that you're not displacing all the ceiling insulation with the duct, there's a requirement that says above and below the duct should total R19, not including the duct R value. And the three examples there are the duct completely, the R19 is completely below the duct, or some sort of mixture between below and above the duct, totaling R19, or R19 at a minimum over top of the duct. So if you look at if you're considering an R8 flex duct, you have R8 on the bottom portion of the flex duct and R8 on the top, and then R19 on top of that. You've really pretty much accomplished well over R30, close to R38, even where it's been, in theory, displaced due to the duct being there. So for those of you who aren't intimately familiar with the climate zone map that's part of the IECC, both residential and commercial, but kind of a side note for 90.1, this is no longer the climate zone map for ASHRAE 90.1, but for this purpose, climate zone 1A, 2A, and 3A, which is within that the red box. If you see at the very top, we have the three different moisture regions. A is basically East Coast, Midwest. Dry would be, for the most part, the mountainous and desert climate zone, and the marine would be along the Pacific coast. So this is an issue that's related, right? Moisture region, well, climate zones 1, 2, and 3, which incidentally is where the vast majority of at least the majority of the building within the United States is going on at this point. And so there, the duct, because of the moisture and the condensation concerns, R13 or greater for the duct insulation, and everywhere else in the country, including Hawaii, would be an R8 or greater insulation for the duct. So how do you achieve an R13 duct? For the most part, it's not commercially available, other than you can take just a bare metal duct and wrap it with R13 insulation. An R13 blanket insulation you wrap with, just like they wrap it with R5.6 or R8 right now with the metal duct. Or what Stephen Winters had frequently been using in their research had been the encapsulated duct. So they would take a typical duct and encapsulate it with 1 inch or 1.5 inches of closed cell sprayed polyurethane foam. As you can see, it's a little on the messy side, but it's done properly. It's absolutely a great solution. And in the interim, before it becomes commercially available, the research that Home Innovations had done with trying to show the performance of a higher R-value duct, when they were using flex duct, they did concentric R8 ducts. I believe they were both R8. You could do an R8 or an R6, and you're right on the cusp of R14 or over R13, so you meet the requirements with that type of solution. We've spoken to some of the flex duct suppliers, and They say they're ready to go if there's a demand. So they're willing to participate in this if there's people asking for it. So here is the actual, with some permission from ICC, the actual code change proposal that explicitly allows ducts to be buried within the attic insulation, and these were the three components that I had just mentioned. That no less than an R8 value. The R19 is the minimum above and or below the ducts. Climate zones 1, 2, and 3A must be an R-13. And the one exception here is that the last 3 feet of the duct don't require to comply with these requirements. And the reasoning behind that, as you can imagine, when we were putting the code change proposals together, we were concerned that we didn't want to go overkill, but we also didn't want to. We didn't want to stop builders from doing what they were already successfully doing and make it more difficult for them, especially when we're talking about the R-13 duct. And so if they're coming in, we'll say from an elevated position in through the insulation, it could potentially be interpreted that, well, that last couple feet is really buried within the insulation, within the ceiling insulation. So we wanted to make it clear that this exception, it was not required that you had to have an R-13 duct for that last 3 feet. So the second proposal was saying, if you deeply bury the ducts within the attic insulation, then you can get credit for it. And when I say credit for it, this would be a performance path credit. So ducts or portions of the duct installed as deeply buried, they claim this R25 R value. And when I say may claim, so when you're doing a performance path calculation and you enter the duct, they ask you, where are the ducts located? Are they in conditioned space? Are they in crawl space? Are they in the attic? Are they buried in the attic? And I would suggest that if you're going to do this type of performance modeling for code compliance with the performance path, not the ERI, but the performance path, that you they consider it exposed duct with an R value of 25. And this is something that can be evaluated on, let's say you have 100 linear feet of duct in the attic, and half of it is buried and half of it is not buried. You can actually parse that out when you're doing your data entry to distinguish between deeply buried and not deeply buried ducts. And get the R25 for the deeply buried ducts, and if they're exposed, then you just put the R8 or R6 or whatever the insulation level is on those particular ducts. As far as the duct location, it has to be within 5.5 inches of the ceiling drywall, and a couple reasons for that. One is to be able to go above 2x6 studs, so you could drape it across the studs. Or if you're having a takeoff on a duct that's over a 2x4 bottom cord, that you can be a couple inches above that as far as your takeoff on that on the main trunk line, and still meet that 5.5 inch maximum. And also the ceiling insulation, and maybe the language wasn't perfectly crafted here, but the R30 surrounding the duct was really implied to be the insulation, the attic insulation, not the horizontal R30, to the left and the right of the duct. I don't perceive that as being a problem, but at this point, it could potentially be interpreted either way. But I don't see either one being a problem. And so here's the actual language for this RE110, which is the designation for the proposal on the effective R value of deeply buried duct. Again, showing the 5.5 inches, and make sure that the R value is 30 around it, and not less than 3.5 inches below the top of the insulation, and shall be considered as having an effective duct insulation R value of R25. So the third component was ducts being located in conditioned space. And so there's 4 requirements that were part of that proposal. And one is that it needs to meet these requirements. As I go back up a slide, these requirements for the duct being buried within ceiling insulation. So first of all, it has to meet all those requirements. And then the air handler must be within conditioned space, so you can't have the air handler in the attic. And third, the duct leakage has a very aggressive number. The post-construction, it's a post-construction test because it will be leakage to the outside of 1.5 CFM per 100 square feet of conditioned floor area. So the requirements right now for ducts that are outside of conditioned space is 4 CFM per 100 square feet, and that's a fairly aggressive number to begin with. And now to turn that into 1.5 CFM is quite aggressive, and I would only suggest this for builders that are very confident in that they can do this and they can do this repeatedly. So there's some concern there, but it's not unachievable. It's just something that should be taken into consideration before you do it the first time. And this number is actually even more stringent than the DOE Zero Energy Ready Home requirement, which requires ducts to be in conditioned space, but it has essentially an exception if you're at 3 CFM per 100 square feet and you're under 3.5 inches of insulation. Well, here it's 1.5 CFM per 100 square feet, and point number 4 here says it basically has to be under the requisite amount of ceiling insulation that's being used for that, being proposed for that particular house. So if it's, for example, R38 is the requirement, then you have an R8 duct, you need R30 on top of that, so you meet that R38 requirement. So you need to have basically the full amount of insulation, and it needs to be a super tight duct. So that's kind of the summary, and the ducts need to be in the air handler must be located in that conditioned space. So here's the actual language for that. Pretty much mimics with what I just indicated. So implementing the buried duct with previous code additions. The 2018 IECC was just published. It was published in, I believe, early September. And at this point in time, no jurisdictions are on that code. They're all on previous versions of them. So buried ducts can still be implemented using a provision for alternative compliance. It's alternate means or alternate materials design methods, which is IRC section R104.11. And most code officials are pretty friendly to accepting options that are included in newer additions to the code. So I wouldn't perceive that as being a problem if you reference the 2018 So when you're doing performance path or ERI compliance, 2018 code has reduced energy usage options to be claimed towards compliance with using both the performance path and the energy rating index. So based on installation, this includes deeply buried R8 ducts, where you can use the R25, and you can consider the ducts in conditioned space, as I indicated. If the air handler is in conditioned space, you meet the 1.5 CFM, and there's proper amount of insulation above that duct system. I did some energy modeling and came up with some interesting results using 2 different commonly used pieces of compliance software that are out there. I won't name them, it's not important. So if we were to start with a house that just barely complies with the code, this particular house is, I think, around 2,000 square feet, located in the Dallas-Fort Worth area, slab on grade, just meeting the requirements of the 2018 IECC. So if you look at A and B on the far right for IECC performance path, so in theory, these two houses just barely comply with the performance path. They just make it 0%. It's right on the margin. And to the left are the two corresponding ERI scores for that particular house. So as you imagine, now if you're going to take that R8 exposed duct in the attic with this 4% leakage that just meets the code, and you vary it, now you can claim R25 duct insulation. And pretty much across the board, about 2.2 ERI points, and both software A and software B, about a 2% meeting the minimum IECC requirements with software A, 3% software B. Not really much distinction between there. So it shows that there is a benefit. Just strictly bearing the duct gave you roughly a 2% or 2-point improvement towards code compliance. And also, as you can imagine, as they get tighter, going to 3%, 2%, 1%, and 0%, you get a nice smooth, reduction in your ERI or increase in your IECC performance path above the minimum requirement. But what's interesting was, and this is based on the way the language is specifically written, and I had discussions with both software manufacturers, and they understand the concerns or the inequity of this. But if you take that same house that just barely passed this attic exposed, the very first one, 0% right on the margin, and you bring those ducts from outside condition space to inside condition space using the IECC performance path, they all fail. Anywhere from whether it's tested to zero leakage, whether you took the testing exemption, with the performance path, they fail. And in the case of the testing exemption with software A, it misses by 6%, so not a trivial amount. So where I'm going with this is, if you're going to use the performance path, you might not want to consider those ducts in condition space. You might want to model them as if they're deeply buried ducts, and you'll probably come out ahead. But if you're using the energy rating index, that has a fixed baseline. So the baseline is defined, and it holds true for all simulations. The way the performance path, it does not define a location of the duct. Therefore, if you move the duct, if the duct is outside, it's compared to an outside duct. If you move it inside, it's compared to an inside duct. And there's some nuances in there that really kind of throw this off. And it shows up in this particular modeling scenario. And something that I've already discussed with DOE, and I think we need to continue that discussion. And hopefully we can have that resolved. Unfortunately, it's going to take 3 years to resolve it. And the footnote here, ResCheck does not model duct performance, so it wouldn't be applicable under doing this as a ResCheck, even though the performance portion of ResCheck would not allow modeling of ducts to this level. So the conclusions are the 2018 IECC has changes that will specifically allow buried ducts where it was ambiguous before, along with requirements for buried ducts. Code changes also give energy credit for deeply buried ducts that result in about 3% or 2 ERI points. And properly installed ducts can be considered in condition space, which works in the ERI path. However, caution should be used when considering these options in the performance path. So it could be beneficial to consider the ducts outside of condition space. And also, I need to consider that the delivery temperature will be lower and can increase condensation potential at the register booth. So I'm not saying it's going to happen. I'm saying that if you're right on the margins to begin with, that you're beginning to push your luck. So that's all I have for the presentation, and I'll let Pam take it for a little bit, and we'll have some questions.
Oh, thank you, Craig. That was very informative, and I really appreciate you taking the time today to go over that and the changes in the 2018. You can go to the next slide. with that, where can you go with some resources? Craig did a lot of good information, and we have some areas that you can go out and pull some of this. First of all, if you don't have the 2018 IECC, it is now available. It just got published. They had a delay. So we just did publishing, I think it's been 2 weeks now. So you can go to IECC and purchase the 2018 if that's applicable in your area or you want to see what's in there. Resources that the Building Energy Codes program has. Compliance software. Craig talked about ResCheck. It is true that does not model ducts. It doesn't mean you still can't use it, but not for these measures. You can show them separately if you wanted to, but it's still going to go off the prescriptive path based on the code that you've shown in that software. There is other software that's available out there, and I'm not sure as far as where they're at with modeling. Technical support, the codes program does have a help desk. If you have questions related to the national codes or the software ResCheck and concepts, you can send them through the help desk. There's a link down below at the bottom of the slide. We have some code notes that are available out there, a lot of good publications. Codes program does have a lot of great information. If you haven't been out there, go skim around some pages and see what's there. Resource guides that are available, and then training materials. This recording, like I said, will be posted on the Energy Codes website under the training page. We also have a whole slide deck of all the codes and working on the most recent one. So if you're a trainer out there, we do produce the entire code, actual Energy Code and 9.1 slide decks. There's some commercial that you can just go grab and use at will. And next slide. So let's talk about some additional resources. There's another DOE program that kind of worked together, and Craig talked about how Building America did the research behind this effort to get this into the codes. And here is the Building America Solution Center. This is a great resource for builders. A lot of good information, leading technologies, going to market, in market that are out there. And I was just showing you a couple things real quickly. But if you go to the homepage, and the link is up there, on the dasc.energy.gov, you can go through a variety of things, but the guides, there's hundreds of guides in there. And I'm just giving you a brief overview of where the buried ducts are, because this information is there, and there's an actual code base that you can go pull that has the actual code sections from the 2018 that are in there as well. So this is going to be, you go in, you can click on guides, see the whole link of, all the different guides that are available. There's about 7 or 8 that are on ducts itself. And I'll even click on code base and go through and view the code base that are available. There's like 35 in there right now, and there is one that's on buried ducts. Next screen. And here's a screenshot if I was to go to a guide, and this one's on the buried ducts. And what the guide has, how it's set up all these guides in the Solution Center, is the tabs at the top take you through a certain measure, a specific measure. You can click on the scope, and then you can go to the description of what the measure is. Success, climate, any information that has to do with climate, any training materials that might be applicable to that measure, CAD drawings, compliance tab. If you're really interested in just showing compliance or what the code provisions are for any of these guides, or the one we talked about today, you click on the compliance tab and it's kind of trying to go through. It's in a format, so to speak, that we have the zero energy at the top. We have Energy Star, and then we list out there a national code. Most of the measures that are in America are above code. These are leading technologies that are available out there. So you'll see those programs initially first. And then there's more information, and then of course there's some cells. There's other things available in this tool. There's a toolkit, and just a whole bunch of information. Please go take a look at the Solution Center. I think you're really going to like it if you haven't been there. And let's go to the next slide, and it's just showing you a screenshot of the code base of what we've been talking about today that Craig has. If you have to click on the compliance tab or link to the code base, the left-hand nav that says code base there, and you found the one you wanted to look at, and this one on buried ducts, it's set up in a format as well. So there's a brief overview of the measure, kind of going into if there's any history around this, and did it get into code, is it not into code? Some of these code base, this measure might not even be addressed in code, and that's where these come into play is this a code barrier? Do we need to have more information? We've done the research, we can show that this is great information. Let's not have this sit at a code official's desk and him not approve it. So the intent of these code briefs are, let's put the builders and the code official on the same playing field. Let's give them this information, make it easy so the code official don't have to go read a 100-page report, and we're going to put it and just kind of condense it all into this nice code brief. So part of it is an overview, then there's a plan review section, and then actually lists out the code section for your plan review. But it's also for the builder as well. And then there's a failing section that kind of goes through what sections of the code are related to inspection, and what do you need to know, checklist items if you were going out and inspecting this measure. Really great resource are these code briefs. We put a lot of good stuff about them. So go out and take a look at those. And we'll go to the next slide, and then we're going to address questions here in just a few minutes. One more thing to talk about is 4D's Building Research Program. The webinar brought to you today is if you have any training topics or ideas that you'd like to see, again, we have these webinars every other month, same time, Thursday, 10 o'clock Pacific time. And send us your topics, ideas. You can send it to the link here. You can send it to our help desk link that I provided. Yeah, please do. We want to know what's of interest to you or what you're seeing out there in the field that you need more information on. Again, thank you today. And now let's take a look at questions. Craig, are you ready to address some questions?
I think so.
Okay. We have a lot that came in. Let's take a look at number one. It's a long one. Can you tell because I start talking? Can a builder use PVC pipe wrap and wrap the pipe like a concentric duct with insulation? Will that meet the code requirement? So can a builder use PVC pipe and pipe wrap like the concentric duct with insulation? Will that meet the code requirement?
So now if you're talking about the PVC pipe being the actual duct and then putting insulation around that, that now you're starting to get into, smoke development and flame spread and things of that nature. So I'm not comfortable making that call. I know that plastic pipe generally is not acceptable. It is for some of the high pressure, like when you get the 2-inch diameter solution out there. But in general, PVC pipe is not acceptable. You'd have to check with your code official on that.
Building Method does have a research project. If you're interested, it's called Plug and Play. It's a new plastic deck system that they're designing. They've been working on this for a couple of years now. I think they're getting close to go to market or actually gone out and doing some pilots. If you are interested, they've gotten code officials together. They've been trying to address this issue of PVC and ducts. So here's just another research project. Still dealing with ducts, but you might want to go take a look. And it's not on Building America. You can go out there or on the Solutions Center. There's some information there. So if you're interested in that, then we'll go take a look and see where they're at with their research and their studies. Next question. I want to try to get a copy of this presentation. We will have that available on the training page on the energycodes.gov training page. So if an aerotic duct is suspended in aeromatic and you don't have much condensation potential, then why does the condensation potential go up if RA is buried in the additional insulation?
Okay, that's a very good question. I probably should have spent a little bit more time on that. So what happens is on the inside of the duct, the R value or the temperature is, we'll just throw out a number to say it's 50 degrees. And if it's 80 degrees in the attic, as you work your way and you bury the duct is exposed, you essentially have 80 degrees the surface temperature on the duct where the vapor retarder is located is going to be much colder. So it's going to be closer to the dew point, and so the closer you get to the dew point, or when you pass the dew point, that's when the condensation occurs. So the deeper you bury it, the closer the surface temperature of the duct is to the air that's inside the duct, as opposed to when it's exposed in the attic where the temperature is 80, 100 degrees. I mean, you never see at least in the United States, you'll rarely see an 80-degree dew point. But when you get closer and closer to that 50 degrees, the increased potential for condensation, and when you're in the humid southeast, anywhere the Gulf Coast, you can frequently see dew point temperatures in the 70, 75 degree range. So when you get below that, now you have that potential for condensation on the ducts. And when that occurs over extended periods of time, that's when you start getting the dripping and the staining and the mold. And so the higher the R value is on on the duct, before you higher the temperature will be down the duct and
you're cutting out.
reduce potential.
You're kind of cutting out there.
I am?
Yeah, so if you didn't get all that questions addressed, send it in again to us and we'll answer it. We can do it via email. Couple questions came in, Craig. I'm going to summarize them. A lot of it has to do with the R-13 in those hot humid climates where you have to add the additional insulation. And there's a builder checklist saying, okay, we can't find it where we're doing double insulation on our decks. Is there anywhere it's available, commercially available? And there's another one, the same thing. There's some manufacturers out there. So we do have a couple that came in on that issue. So if there is, I think we talked about it a little bit about the R-13. So what's some good ways that we can get around meeting that measure?
Well, I showed the three different examples. One of the trunk line that could be wrapped in like an R-13 blanket. So that's one way to do that. The second was the encapsulating with the spray foam, and then the third was the concentric. Those are three things that are available now. I really haven't gotten a firm time frame on when any of these manufacturers are looking to do that. It's my understanding it's not that difficult to do. It's just putting another part number together or product line together that it shouldn't take too much work on their end. But this is kind of a chicken or the egg. Do they put it out there and wait for people to use it or to buy it, or do they wait till people start asking for it? So I'm going to continue to prod the industry to see if they're going to make these products available.
Okay. Can you put that again, the air handler? If that's the build, does the air handler have to be in the conditioned state?
So the air handler has to be in conditioned space to be able to call the entire system in conditioned space. So you can still have the ducts go up into the attic as long as it has the proper amount of tightness as tested with leakage to outside, and the proper amount of insulation over top of the ductwork. But if you're going to just do the deeply buried approach, then the air handler can either be in conditioned space or not in conditioned space. That's not a prerequisite.
Okay, great. Let's take one more here, and we'll kind of wrap it up. I have one here. There are sections of the duct for 3 feet or less. Does that need to meet the R-13 or not? Need to or not need to meet the R-13, and what's the reason? So the
I'm sorry, Pam, could you repeat the question?
The sections of duct that are 3 feet or less, that doesn't count towards meeting the R-13, and what's the reason? I said it wrong to you.
So that exception applies to all of those points for buried ducts, and the whole purpose was to avoid any confusion with the code official for ducts that are elevated above the insulation and going through the insulation to the boot, to come in to the ceiling. And so R-13 is not required, and any of those requirements for a buried duct does not apply to that type of installation. And we just, again, the whole point was to make it clear. I didn't want to have any confusion, so a builder would have to do something now that they didn't have to do before. So we wanted to avoid that, and that's why the exception was put in there.
Good. Okay, well, I want to thank Craig for taking the time to present this material to us today. Everyone, appreciate your time, and you can all disconnect. We're going to end the webinar in just a couple minutes early. Thank you.